Welcome to this new module. Here we will examine the material requirements for mountaineering footwear where thermal insulation, mechanical strength and environmental resistance are key factors. Mountaineering has experienced a surge in popularity, evolving from a niche sport into a form of adventure tourism. However, mountaineering is a high-risk activity, and one of the most significant dangers is frostbite. Studies have revealed that a surprisingly high percentage of mountaineers, over the 70%, in some randomly selected groups, have suffered from frostbite. The overall risk of frostbite injuries among alpinists can reach as high as 37%, highlighting the critical importance of proper equipment and understanding of the physiological challenges. The feet, often described as the radiators of the human body, present a unique challenge for thermoregulation. Their thermal behavior is not easily predictable due to several factors. They possess a large surface area relative to their volume, and they are in constant contact with the ground, making them highly susceptible to conductive heat transfer. Inside the boot liner, heat transfer is governed by both conduction and convection, driven by the heat flow from the foot itself. Crucially, the insulation properties of footwear are directly proportional to the amount of air trapped within the fabric and between the foot and the boot. Another essential feature of high-performance mountaineering boot is its ability to effectively manage and expel moisture from the inside to the outside, preventing the buildup of sweat, which can drastically reduce insulation. In summary, while the key properties of the sole and the midsole deal more with the design to avoid slippering and improve ground gripping, the key design considerations for the upper are insulation, maximizing heat retention in extreme cold, moisture management, efficiently wicking away sweat to prevent freezing and maintain insulation. The fundamental principle underlying thermal insulation is the use of air. Air is one of the best thermal insulators known, possessing a very low thermal conductivity, approximately 0.026 watt per meters Kelvin, at ambient temperature, of course. Therefore, the primary goal of insulating materials is to trap as much static air volume as possible within the structure, preventing convective air movement and drastically reducing heat transfer. In cold protection systems, and particularly in mountaineering footwear, various insulating materials are employed, each with a specific property. Goosedown stands out for its exceptional warmth-to-weight ratio and its remarkable loft capability, its ability to expand and trap a large volume of air. From an engineering perspective, its three-dimensional structure, composed of millions of soft interlocking filaments, creates a micro-pockets of stationary air. However, its performance degrades significantly in the presence of moisture. Classic batting refers to traditional synthetic insulation, often made of polyester fibers. Their insulating effectiveness derives from the density of the fibers and their thickness, which allows them to create a porous layer capable of trapping air. While they may be more voluminous than down, their strength lies in their ability to maintain a significant portion of their insulating power even in humid conditions, as synthetic fibers tend not to absorb water and retain their structure more effectively. High-performance functional fillings like ClimaShield, Primaloft, or Thinsulate represents the cutting edge of synthetic insulation technologies. Their engineered encapsulation is based on sophisticated fiber manipulation. Fine and crimped fibers. Extremely fine fibers, often in the micrometer range, that are crimped, This crimping makes them voluminous and allows them to interlock randomly, creating a complex network of micro-interstices. The surface of these fibers are often treated to be water repellent, as in the case of Primaloft, which allows the material to maintain its insulating capabilities even when exposed to moisture or wet. Moreover, the ability of these fibers to return to their original shape, the resilience, after compression is crucial for maintaining the trapped air volume over time and under stress. Also, they are known for their low thermal conductivity. Another option is the PLA fiber. Polylactic acid is an innovative fiber derived from renewable sources like cornstarch. Although not traditionally known for insulation as much as polyester-based synthetic or down, the use of fiber with a specific fineness allows for the creation of structure that can effectively trap air. Its inclusion here highlights the growing interest in more sustainable insulation solutions, while still adhering for fundamental principle of air entrapment for thermal insulation. Studies indicate that the average sweat accumulation inside footwear is approximately 20 grams per foot per day, with a range that can vary from 10 to 30 grams. Of this amount, a certain amount tends to remain trapped within the socks. Naturally, the quantity of sweat produced largely depends on the physical activity performed and the environmental condition. To counteract sweat accumulation and ensure lasting comfort, technical footwear employs advanced materials and structure, often polyester-based, due to their inherent moisture management properties. Some examples could be polyester warp knitted spacer fabrics and 3D mesh. These fabrics are composed of two distinct fabric surfaces connected by vertical monofilament fibers, creating a defined three-dimensional space between the two faces. This spacer structure not only provides cushioning and uniform pressure distribution, but it is also fundamental for moisture management. The polyester fibers, being hydrophobic, facilitate the capillary transportation of liquid water along their surface. Critically, the three-dimensional space created by the monofilament acts as a ventilation channel and air reservoir, promoting the circulation of water vapor and preventing direct contact and adhesion of wet skin or socks with the outer upper. Coolmax is a registered trademark for engineered polyester fabrics, featuring a distinctive cross-sectional morphology. Unlike traditional round fibers, Coolmax fibers typically exhibit a four-channel or multi-channel structure. This unique design significantly increases the specific surface area of the fiber and creates a highly efficient network for internal and external capillaries. This maximizes capillary force, enabling the fiber to rapidly pull the liquid water or sweat away from the skin's surface and spread it over a larger area. Being polyester, Coolmax fibers are inherently hydrophobic, meaning moisture is quickly transported away and not absorbed into the fiber itself, accelerating fabric drying times. In conclusion, their capacity to create pathway for both water vapor transport and liquid wicking, combined with their rapid drying nature, is essential for maintaining thermal comfort and mitigating the risk associated with moisture in cold, confined environment. This concludes our module on materials for mountaineering footwear, where protection and thermal insulation are key. In the next module, we'll explore how numerical simulations are used in the sports field to predict material behavior, optimize product design, and support performance analysis.